Serial communication is sending one bit at a time. That's essentially what it means. Now, in this context, and often you'll see the term serial communication used this way, serial means UART communication. UART is a specific serial protocol that we've talked about. We're going to talk about more, too, in the class. But it's a specific serial protocol. The term serial really is more broad than just UART, but it is often used interchangeably. And specifically in the Arduino context, we're going to use this serial library, serial communication library. And it's called serial, but it is a UART communication library, so you should be aware of that. Okay, so we're using UART protocol over a USB cable. UART protocol needs, say, 3 wires, right? One transmit, one receive, and then another one for the common ground. And there are other wires you could use, but those are sort of minimum. And it sends one bit at a time in one direction to the other. Or actually, it can send both directions at the same time, so it's got 2 different wires. But you need those wires. So you can connect to a microcontroller or an integrated circuit and communicate just via wires. But it is most common in bigger systems to use the USB cable itself. So from the Arduino to the laptop, when they want to communicate with each other, they communicate over the USB cable. And they can communicate, when you're using the serial library, they are communicating using the UART protocol over the USB cable. But it wasn't originally that way. There was another cable, RS-232, that was originally made specifically for this protocol. But, that's not installed in machines anymore. So now people just do it commonly over the USB cable. So the way you start serial communication in Arduino is you have to call this initialization function serial.begin. And typically you put that initialization function inside your setup because you only want it to be executed one time. You don't want it to be executed in a loop. Now, serial.begin, it can take 1 or 2 arguments. If it's one argument, that argument is the speed. And if it's 2 arguments, then the first argument is the speed and the second one is the configuration. Now, the speed is the baud rate. That means the bits per second that you're sending, the number of transitions per second on the line, which is essentially the bits per second that you're sending. And these are not all data bits, note. So even if you have a high baud rate, remember that the data rate is a little bit less than that because there's an overhead. There's a stop bit and a parity bit and other things that we'll talk about, okay? But baud rate is a number of bits per second. So, and there are certain baud rates that are common in serial. You can use any one you want. There are certain common baud rates, like 9600 baud is a common baud rate. Now, note that the faster the baud rate, the faster the data transmission, right? So that sounds good. You want to transmit as fast as you can. 9600 baud is pretty slow, right? 9600 bits per second is pretty slow. But there's a limit to this because there's a synchronization that goes on between the 2 communicating parties, okay? They have to know they have to be timed in sync, right? And the synchronization fails once the baud rate gets too high. Okay, they don't synchronize well. So not often, but sometimes in practice, when making an IoT device or analyzing a device, when I'm communicating with the device at a particular baud rate, often just slowing down the baud rate will make it work. So maybe at a high baud rate, it doesn't work because they're not synchronizing well. But if I just slow it down, then they synchronize fine and everything's okay. The synchronization goes wrong because of noise errors in the wires and stuff like that. A long wire, stuff like this will cause problems. So just slowing down the baud rate is often helpful. Okay, so speed is the first argument, and you have to give that argument. The other argument is a configuration. So this sets the properties of the communication, basically the bits that you're sending. How many data bits, how many parity bits, or are you sending a parity bit rather, how many stop bits, and so on. So there are a set of constants that are defined for that in the Arduino library. So one thing you could call a serial.begin 9600, that's sort of common, and that says, okay, send it at 9600 baud rate. Now, you can also try this where you give the second argument, and this second argument is telling it's a constant that is associated with some certain configuration. So that's serial 8N1. That means, and you just have to look this up, but what that means is 8 data bits, no parity, 1 stop bit. Typically, we're not going to use a second argument, not in this class, because we're going to use the default. That's actually the default. We're going to use the default configuration, and that's fine for us. But you can change that if you wanted to for any particular reason. Okay. So, again, with Arduino serial communication with the library, there are several different functions that you can call. Now, the first function we already talked about is serial.begin. You call that in the setup one time. But there are other functions you can call to send data from the Arduino to the other device, in this case, to the laptop, let's say, over the USB cable. Serial.print is sort of a very common function to call. Serial.print does basically what you would think. It sends a string, okay? And it sends it to the laptop. Let's say it's a laptop. It sends it to the laptop over the USB cable. Now, what happens when it arrives there is that the Arduino sending via serial, there has to be a receiving program running on the laptop to receive the serial communication. Now, typically, what we're going to do is if you look at the Arduino IDE, there is a button on there it says Serial Monitor. You click on that. It opens up a window. In fact, the window that we see here. It opens up a window and it's blank. And then when the Arduino is running and when it calls serial.print, say, hello, that hello is sent over the USB cable to the serial monitor running on the laptop, and then that whatever text it was appears in the monitor. So that's what we're seeing here. Now notice that it's just saying hello, 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 hello over and over, right? That's because, I'm not showing the whole program, but that's because I put the serial.print hello inside the loop function in the Arduino sketch. And so it just loops and does it over and over and over. And so that's what we would expect to see. Now notice there's no carriage return after the hello, right? It's just hello, hello strung out after each other. If I did serial.print line, ln, it would put a carriage return after one, and each one would be on a different line. But this is what I chose to do. So this is the general idea. Now, something about UART is that UART is a protocol to send bytes, to send 8 bits. And this 8 bits of data can be just raw data. It can represent anything, okay? Now, in this case, though, with serial.print, we are generally representing strings, printable strings, right? Serial.print hello, in quotes, right? This is a string, 5 characters. So there are 5 characters that we need to send via UART over to the laptop. And so the thing is, remember that we're sending bits, like sequences of bits, sending 1 bit at a time, zeros and ones. So each one of these 5 characters has to be represented as a sequence of zeros and ones in order to be sent via UART. That representation, the most common representation for small things like this is called ASCII code, ASCII. So if you Google this, you'll find the ASCII code table. It's a big table. And it's an 8-bit representation of most of the characters that, at least in English, that you want to represent on the screen, right? So all the characters on your keyboard plus some more, each one of them is associated with a number, an ASCII code number. So, for instance, I happen to remember off the top of my head, a capital A is a 41 in hex, okay? That's the only one I remember. But each one of these characters is associated with a number in a big table. And what happens is, and this number is an 8-bit number, okay? So what happens is when you call serial.print, it says, okay, I've got 5 characters. It says H, that is, say it's 51. It picks a 51, represents it as an 8-bit number, and sends that 8 bits to the laptop, to the serial monitor. The serial monitor receives that 8 bits and says, oh, this 8 bits must be ASCII code. It looks up that ASCII code character, that number inside its table, says that's the letter H, and it prints an H on the screen. Okay? That's how the data is sent and represented on the screen. So this ASCII code is just an 8-bit code for every character that you want to display. And that's what's actually being sent over the wires, this ASCII code representation. Now, I'm talking about ASCII. That's an 8-bit code, and that's limited, right? Because if you only got 8-bit code, you can only represent 256 characters max. Now, in English, that's fine, but especially when you get to like Chinese or something, you got a lot of characters, and 256 will not cut it. So you need more. Not just Chinese either, but there are other scripts, but Chinese particularly, it's all character-based. You got a lot of characters. Plus, there are other characters besides letters, periods, and all kinds of weird characters that you might want to represent on the screen. So 256 is not really enough. So now people use Unicode, 16-bit character representation. But for now, we'll talk about ASCII. So this is the idea. These numbers, each one of these characters is represented as an 8-bit number out of an ASCII table. You can Google it and look at the table if you want to. Those 8 bits are transmitted, and then they're printed on the screen at the receiving end. They're re-represented as the original character that they represented. They're put on, and that's put on the screen. Now, that's what serial.print does. Now, instead of using serial.print, you might want to use serial.write. Now, serial.write, it also sends bytes to the screen, but it sends 1 byte at a time, right? So you remember with that serial.print hello, you had in quotes a string, HELLO, so it sent 8 characters, which meant 8 bytes. Sorry, 5, I'm counting wrong. It sent 5 characters, which means 5 bytes. In this case, serial.write, you just give it one argument, which is a number. Okay, that number, it represents that as a byte. So like in this case, serial.write 42. It represents that as a number in binary, a sequence of bits in binary, 8 bits. It sends those 8 bits to the serial monitor. Now, the serial monitor, it receives those 8 bits, and again, it does what it did with serial print. It looks at those 8 bits and says, okay, what ASCII character does this represent? And the ASCII character is what gets printed on the screen. So notice, even though you're doing serial.write 42, 42 is not appearing on the screen. Because what's happening is on the receiving end, it's taking that from 42 and interpreting that as an ASCII character and saying, well, which character is represented by the number 42? It happens that it's an asterisk in this case, so that's why we got asterisks appearing all down the screen. So that's what serial.write does. It sends a raw byte. You just give it the number, it interprets it as an 8-bit number, and it sends that. And it gets represented in ASCII at the serial monitor because that's what serial monitor does.